Hi, Assalamualaikum. This is our video presentation, CHM301. Our title is Benzoic acid and our lecture name is Autotono Wibowo. So this is our members. My name is Muhammad Amirabi Ahmad Munif. You can call me Miro. And second member is Muhammad Nasrullah bin Muhammad Alizan. And you can call Nas. Lastly, Muhammad Khairul Shazmi bin Kamal Effendi. And you can call Kai.
Hello and welcome. Today we're going to take a quick look at an important organic compound, benzoic acid. Benzoic acid is one of the simplest aromatic carboxylic acids. Its chemical formula is C6H5COOH and it consists of a benzene ring attached to a carboxylic acid group. This white crystalline or solid occurs naturally in many plants and serves as an intermediate in the biosynthesis of many secondary metabolites. It also appears in small amounts in certain fruits like cranberries and prunes. Benzoic acid is perhaps best known for its use as a food preservative. In its salt form, sodium benzoate, it inhibits the growth of bacteria, yeast, and fungi, helping extend the shelf life of acidic foods and beverage. In the laboratory and in industry, benzoic acid is also used in the synthesis of a variety of other organic compounds such as dyes, plastics, and perfumes. It's slightly soluble in water, more so in hot water, and it dissolves readily in organic solvent like alcohol and ether.
Now for the next part is physical and chemical property. A physical property is an observable characteristic such as color, odor, melting point, conductivity, polarity, and density. A chemical property is a characteristic that is observed during a chemical reaction, which can include flammability, reactivity, toxicity, heat of combustion, and acidity. Hey guys, Kai here. In this slide, I'm gonna talk about physical and chemistry properties of benzoic acid. For physical properties of benzoic acid, we have 10 physical properties. The first one is molecular formula. The molecular formula for benzoic acid is C6H5COOH. The second one is the molar mass. The molar mass of benzoic acid is 122.12 gram per mole. The appearance of benzoic acid is white crystalline powder or needles-like. The odor of benzoic acid is faint and pleasant odor. For melting point, it is 122.3 Celsius or 252.1 Fahrenheit. For boiling point, it is 249.2 Celsius or 480.6 Fahrenheit. The density of benzoic acid is 1.27 gram per cm cube. Benzoic acid is lightly soluble in water. It is also highly soluble in organic solvent. For example, ethanol, ether, benzene, chloroform, and acetone. And lastly, benzoic acid is a weak acid. Now, we'll move on to chemical properties of benzoic acid. Since benzoic acid is a weak base acid, it will dissociate in water to form benzoate ion. When reacted with base solution such as NaOH, it will form salt. In esterification, when reacted with alcohol in presence of an acid catalyst, it will perform ester. In decarboxylation, when heated with soda lime, NaOH plus CaO, it undergoes decarboxylation to form benzene. In electrophilic substitution reaction, it will undergo reaction like nitration, sulfonation, and halogenation at the aromatic ring. For example, nitration with NHNO3 or H2SO4 form 3-nitrobenzoic acid, which is meta-substitution. For reduction, it can be reduced to benzyl alcohol using lithium aluminium hydride. Formation of acid derivative, it will react with thiol chloride to form benzoyl chloride and can form amides, anhydride, and other derivatives.
Benzoic acid plays a crucial role in food preservation by preventing microbial spoilage, thereby extending the shelf life of various products. Its antimicrobial properties help maintain food quality and safety, ensuring that products remain fresh and free from harmful bacteria, yeast, and mold. Compared to natural alternatives, benzoic acid is more cost-effective, making it a preferred choice for large-scale food production. Additionally, it works well with other preservation, enhancing their effectiveness. Its stability under different processing conditions, such as heat and varying pH level, make it suitable for a wide range of food products. Common use include preserving soft drink and fruit juice, preventing mold growth in dairy products like cheese and margarine, and acting as antimicrobial agent in condiments such as ketchup, pickles, and soy sauce. It also helps prevent unwanted fermentation in salad, dressing, and sauces while extending the freshness of baked goods. In the pharmaceutical industry, benzoic acid serves multiple purposes due to its antifungal and preservative properties. As an active ingredient, sits over 12%, it is used in topical antifungal cream to treat infections like athlete's foot and ringworm. Its ability to preserve the formulation prevents contamination in syrup and oral suspension, ensuring medication safety and stability. Beyond preservation, sodium benzoate is used in metabolic treatment, particularly for urea cycle disorders, where it helps remove excess ammonia from the body. It is also a component in medical ointment for various skin conditions and is found in some cough and cold preparation. Since only concentrations are needed for efficiency, it remains a practical and reliable ingredient in pharmaceutical formulation. Benzoic acid occurs naturally in various plants, including cannabis and cinnamon, where it functions as a protective compound against microbial infection. This natural presence makes it an environmentally friendly option for certain applications. Under proper conditions, benzoic acid is biodegradable, breaking down into harmless substances through microbial metabolism. Many salt and water mechanisms can process benzoic acid, reducing its environmental impact. In plants, it serves as a natural defense mechanism, helping them resist fungal and bacterial attack. Due to these properties, benzoic acid has potential in sustainable application, particularly in green chemistry and eco-friendly product development. In practical use, benzoic acts as a natural preservative in some food products, leveraging its antimicrobial property without synthetic additives. It is also added to animal feed to prevent mold growth, ensuring livestock health and feed safety. Biochemically, it serves as an intermediate in metabolic pathway, contributing to various organic processes. Researchers are exploring its role in green chemistry, where it could help develop more sustainable industrial processes. Additionally, studies are investigating its potential in biodegradable polymer research, which could lead to environmentally friendly plastic alternatives.
In this reaction, benzoic acid undergoes thermal decarboxylation. When heated, it loses its carboxyl group as carbon dioxide, CO2, forming benzene as the final product. This is a common method in organic chemistry to remove COOH groups from aromatic rings. The key point is that the aromatic ring stays intact. and only the side group is eliminated. Although the reaction requires high temperatures, it's a useful way to simplify aromatic compounds and study their core structure. While the carboxylation of benzoic acid is mainly a lab-based reaction, it has important real-world application. In organic synthesis, it's used to produce benzene, a key industrial chemical. It's also valuable in pharmaceutical development, where the COOH group can guide reaction and later be removed. In research and education, this reaction helps students and scientists study how aromatic compounds behave under heat. Though not common in everyday life, it supports the production and design of many materials and medicines we use. In this reaction, benzoic acid reacts with methanol to form methyl benzoate and water. The process is catalyzed by concentrated sulfuric acid, which speeds up the reaction and drives the equilibrium towards ester formation. Mechanistically, the acid first protonates the carbonyl oxygen of benzoic acid, increasing its electrophilicity. Methanol then attacks the carbonyl carbon, forming a tetrahedral intermediate after a series of proton transfers. A molecule of water is eliminated, and the ester methyl benzoate is formed. This ester has a pleasant, sweet smell and is commonly used in perfumes and flavoring agents. In real life, methyl benzoate is used as a fragrant ingredient in perfumes thanks to its sweet floral scents. It's also found in artificial flavorings and occasionally used as solvent or pesticides, attractant in agriculture. This makes esterification not just important in the lab, but valuable in the industries like cosmetics, food, and farming.
Conversion. This comprehensive study of benzoic acid has examined its fundamental characteristics, practical application, and chemical behavior. As an aromatic carboxylic acid naturally present in plants like cranberries and benzoin, this compound features a benzene ring bonded to a carboxylic functional group, classifying it within the carboxylic acid homologue series. The analysis revealed its distinct physical properties, including its white crystalline form 122 Celsius melting point and limited water solubility, alongside its chemical reactivity demonstrate through esterification and decarboxylation reaction. The investigation highlighted benzoic acid multifaceted benefit across the industry, as food preservative, extended production life, a medical agent in antifungal treatments, and versatile chemical intermediate in plastic manufacturing. Its environmental profile shows biodegradability but requires controlled uses to prevent ecology impact. Two key chemical reactions were present: its neutralization with sodium hydroxide to form sodium benzoate, and ester production when reacting with methanol. This property collectively established benzoic acid as an exceptionally valuable compound, balancing effectiveness with relative safety when properly regulated. Future application may further exploit its antimicrobial properties while developing more sustainable production methods to enhance its environmental compatibility. As you can see, this is our reference page. Okay, thank you for listening. Bye guys.